All right, so to factor by grouping. Some of you have seen this before because you were working on some challenge stuff. Some of you have never seen it. It's fine, either way. You start by putting parentheses around the first two and the second two, okay? Can anybody explain to me why this is not factored now? I just put parentheses on it. It kind of looks like factors. Annika. So there's something else I can do. I totally agree. And Beck, were you going to add something? Excellent. Okay. Also, remember, factors are two things that are multiplied, and these two things are being added. Okay? So that's another additional reason why we couldn't just say these are factored here. The next thing we're going to do is we're going to take out the greatest common factor of each pair. So it's like two mini problems at this point. X to the 3 and 3x squared, do they have a number in common that I could divide them by? Gabby? X squared. Okay, so I'm getting to the x's. You're right. No number, and you're right that we can factor out x squared, okay? So x to the third is x times x times x. It's got 3 of them. X squared is just x times x. It's only got 2 of them. So I can only take out 2 because everybody has to have it. So I can take out the x squared that everybody has, like this. All right, and then that can come out front, x squared. This one is x to the third, so to make x to the third, it has to be x to the 2 times x to the what? To the 1, right? So think about that. X to the 2 is x times x, and x to the 1 is just x. And so if I multiply them all together, I do get x to the 3. That's what I started with. Minus just 3, you're right. Okay. Now, do I have to write x to the 1? I could just write just x, right? I could just write x. I don't have to write x to the 1, but I did write x to the 1. All right, how about here? Is there a number I can divide 5x and 15 by? 5. Good. So let's divide the 5 plus 5. 5x divided by 5 gives me just what? X. And 5x, or sorry, 15 divided by 5, 3. All right. My insides of the parentheses, they look a little bit different. Are they different or are they really the same? I heard one vote for same. Same? Good. They are. You're right. Yeah. Okay, so this is x to the 1. This is also x to the 1. Normally we just write x, so I'm going to continue with just writing x. But this is an important thing. The insides have to match for this factoring by grouping to work. Insides must match. So I'm going to take that x minus 3 down here. And x minus 3 is being multiplied by 2 different things. What's one thing that I'm multiplying x minus 3 by? X squared. Is she right? Is it x squared? It's right here, right? So x minus 3 is being multiplied by x squared here. And x minus 3 is also being multiplied by 5. And that's how we can show it. All right, x minus 3 times x squared, x minus 3 times 5. Now these two binomials are being multiplied by each other. See, no longer added. So these are factors. The only question that remains is, can it be factored further? Can I factor either of these further? Yeah, that's the question. The only thing we've learned how to factor with two terms like this is difference of squares. Is this difference of squares? No, because it's not difference and because that's not a square. All right, so I think we're done with the factoring there. So this one's done. What questions do you have? All right, I am going to do number 2, but I'm going to save number 3. And 2 reasons why I'm going to do number 2. Number 2 says solve. That's new. And also number 2 has a negative in front of this third term, which is going to make things just a little bit tricky, but it's not that bad. Okay. One thing that's weird about it saying solve is because it doesn't have an equal sign, right? If you solve something, it should be equal to something. Can anybody guess what number we have to set it equal to? 0, yeah. So solve, I'm going to write solve for zeros here because that actually should have been explained by the question. They did not give you a clear question there. So to solve for zeros, you just set it equal to 0 like that. And we have to factor it to solve it. So we're going to do the same steps. I'm going to put parentheses on the first 2. For the second 2, that minus needs to stick with the 9. So I'm going to change it to a plus negative. Plus, and then the negative there. So if I could write any smaller, I would put the plus between the 2 parentheses, but I just can't write that small. So plus negative. And then for the first set of parentheses, somebody besides Gabby, somebody else, tell me, what could I factor out?
X squared.
X squared. Very good. So I'll take out the x squared just like I did in the last one. I'll put that here. Just like in the previous one, x cubed divided by x squared gives me x. And in this term, the x squareds will cancel, giving me just a minus 5. All right, the second set of parentheses has negative 9x plus 45. Yes, Alec? You're going to tell me? 9. Okay. Who agrees that we could factor out a 9? One person? 2 people? 3 people? Okay, we could. We could factor out a 9. If we factored out a 9, we would be left with negative x plus 5. Is that going to match? No. Okay, I see a lot of you have ideas, and I appreciate that you're raising your hand to give people a chance to think about it. So we could factor out a 9, but if we want the insides to match, raise your hand if you have an idea of what else we could factor out. Take some time to think about that. I know more than 3 people have that idea. Raise your hand when you have an idea. Good. I'm looking for some more ideas. All right, Ashley, what are you thinking? All right, so raise your hand if you think factoring out a negative 9 would get us the x minus 5 that we want on the inside. Good, good. Are you okay? Okay. Yeah. So 2 good ideas, guys. And as a team, we work together on that. Factoring at a 9 is going to get us the biggest number out. And then turning it negative will make the insides match. So good teamwork there. We're going to factor out negative 9. All right, that gives us x. And then 45 divided by negative 5 gives us the minus 5. So our insides are matching. All right, then just like before, we'll take this inside factor, x minus 5, and we'll think, okay, what is x minus 5 multiplied by? It's multiplied by the x squared and by the minus 9. All right. Who thinks we did it? We're done factoring. Okay. Who thinks that there's more we could do? All right. So actually, after all that talking, not a lot of people wanted to raise their hand. Should we try again? Who thinks we're done factoring? Okay. Thank you for voting, because that lets me know you're thinking. Who thinks there's more we can do? Thank you for voting. Then I know you're thinking. Okay. Raise your hand if you want to suggest something. Katsuka.
Difference of squares. The explains.
Is this difference of squares? It's difference, right? There's a minus? Are they both squares? Yes. Because 9 is the square of 3. Okay, Perfect. So guys, I totally understood from your previous assessments that not everybody was processing difference of squares, and it shows up a few times today, so that's the good news because we get more practice with it, okay? So the reason why difference of squares works is because when you multiply the two binomials, the middle term cancels out, and I'm going to show you an example of that in just a second. Here's the process, and then I'm going to show you an example on the board. To get the x squared, it's the x times x. And to get the negative 9, it can't be 3 times 3 because that's positive. And it can't be negative 3 times negative 3 because that's positive. So what do we need?
Positive 3 times negative 3.
Positive and negative, right. And it does not matter if you want to put the positive first or the negative first. That's totally up to you. All right. All right, so we'll set each factor equal to 0, get 3 different answers. Please feel free to work ahead of me. All right, so we got 3 answers. I don't feel like there's anything new in problem 3, so I'm going to save that for the end of class and turn to the back. So when you're ready, just turn to the back. And on the back, there's some like mixed review. Number 4 does not look that new to me. Which one did I do before? I think I did number 6 last class. I think I'm going to do number 6. Yes. All right, number 6, does that look like the problems we just did? So I can't factor this one by grouping. Let's just start from the beginning. Are there any common factors we can take out? X. So I can take out x, and what was the other one? 2. So I'm going to take out 2x and see what I'm left with. All right, in the first one, the 2's cancel. X to the 3 divided by x to the 1 gives me x squared. (14) divided by 2, 7. And x to the 2 divided by x to the 1 is x. And the last one, the x's cancel, and I get 12. All right. Now, this also doesn't look like what we just did, but have we ever factored something like this before? Yeah. X squared minus 7x plus 12. We need the numbers that multiply to 12 and add to what? Negative 7. Take a minute and find those with your group. Talk to your group about it. Come to this. So, what were the numbers?
Negative 3, negative 4.
Negative 3 and negative 4. Lonnie, who's playing?
Brazil.
Brazil versus?
Croatia.
Croatia. Okay, put it away. We're going to have a break soon, though, okay? After a couple more problems. Who's going to win? Oh, wow. Okay. All right, so, Lonnie, I want you to do super good on this test. Lonnie, focus so we can do really good on this test, okay? All right, so they told me the numbers, the test is going to be next Thursday. Which is good because it means that you don't have to study it over the break, right? Just have a clean slate. So to get the x squared, it's x times x. And then to get the 12, you guys just told me it was negative 3 times negative 4. Those were the numbers that multiply to 12 and then also add to negative 7. And then we're solving, of course, so we're going to set each factor equal to 0. The problems that you do on the board, they don't say solve, so you're just going to factor those. All right, so we just set each factor equal to 0, because when you multiply 3 things and your answer is 0, one of those 3 things has to be 0. No other way to get 0 as your answer. Moving on. We're going to do some of these sum and difference of cubes. Take a look at that. And then look at the problem. Looking at x to the third plus 125, like if I did not know this, if I had not taught Algebra 2 like 5 billion times, then I would not think that x to the 3 plus 125 would be factorable. It doesn't look like it could be anything, but it is. And if you don't believe me, after we factor it, you can multiply them back and see if it works, okay? It does. It's really cool because what happens is, just like with difference of squares, you get a whole bunch of terms that cancel out, leaving you just the x to the 3 plus the 125. So it works. All right, here's how we do it. First, we have to write it as a sum or a difference of cubes. So this one looks like a sum, right? The first one's already a cube. It's x to the 3. And 125, we have to figure out that's the cube of what? All right, so some people know. That's super good. But if you don't know, you can prove it to yourself with a calculator. You could say, well, 1 to the third, that's just 1. 2 to the third, 2 times 2 times 2, that's 8. So I know it's going to be bigger than that, right? Who was the person who just gave us an answer? Somebody told us an answer. So what number to the third is 125? 5, right. So this is 125 is 5 to the third. You can prove that to yourself by multiplying 5 times 5 times 5, and it works. All right. So we have x to the 3 plus 5 to the 3, and then that means that instead of a, we have x. Instead of b, we have 5. And so we're going to use this pattern, and we're going to replace a with x and b with 5. So here's my first one. I've got x plus 5. For my second one, instead of a squared, I'm going to put x squared minus, instead of ab, I'm going to put x5, but I don't really write x5, right? What do I write? 5x, good. And then plus, instead of b squared, I have 5 squared. 5 squared is how much? 5 squared this time, to the second power. 25. Yep. All right. So the reason for factoring is because if you factor, then you're able to solve. So I don't have to solve because it just says factor. But I could solve this one by setting it equal to 0. This one here, I can't factor it further. So I would have to use quadratic formula to solve this one. But good news, I don't have to because it just says factor. All right, one more because I want us to see one where there's a number for each. So we'll do 9. Then after 9, we're going to take a short break, and then we're going to go to boards, okay? All right. We have to write each one as a cube. 27 is what number to the third power? Is it 9 or 3? What do you guys think? Yeah, because 3 times 3 is 9, times another 3 is 27. So 3x to the third minus, what number to the third power gives me 8? Let's try it. 2 times 2 is 4 times 2 is 8. Yeah, it works. So 2 to the 3. All right, this time I'm going to do it in 2 steps, so leave yourself a little space here. This time it's difference of cubes, so I'm going to follow this pattern here. So instead of a, I have 3x, and instead of b, I have 2. When I square a, I'm going to keep it in parentheses so I remember to square both parts. Plus ab, that would be 3x times 2, plus b squared, so that would be 2 squared. I'm going to stop there because that's the hardest part, and then we're just going to simplify it. So notice I'm just filling in this pattern. Instead of a, instead of b. Instead of a, b. 3x is a, 2 is b. So this part's fine, 3x minus 2. And now I'm going to have to simplify this. So I have to square the 3 and the x, and I get 9x squared. I have to multiply 3x times 2, I get 6x. And I have to do 2 to the second, so that's going to give me 4. And that's done.